Okay, this is the third, I believe, video for the first set of circle notes. So if we start at the top, within a circle are congruent circles. Congruent, so I'm going to write the word congruent if you can't read it. And then the next word that goes in the blank, which I can't fit because I'm writing with my finger right now, is arcs. Congruent arcs, or arcs that have the same measure. All right, notice in the circle that you have x degrees on ST, and ST is red. The arc ST is that piece of the circle that's red. And then you have the arc UV, and that's the piece of the outside of the circle that's red also. Those two arcs are congruent. And so what's missing here is over that ST is UV, we should have these little arc symbols, which, again, those are kind of large. But and then coming down to the boxes now, congruent central angles have congruent chords. Okay, so what we know is angle EAD is congruent to angle CAB. They're marked to equal measure, so we know their arcs are congruent. ED is congruent to BC. That's one thing. But then the chords ED and BC are congruent. So remember, the chords are those blue links they've drawn in there. So we would know that that segment ED is congruent to segment BC. Okay. Congruent chords have congruent arcs. The second box, congruent chords have congruent arcs. So if we're told that ED, now this is supposed to go up here, but I don't have room for it, so I'm just going to kind of start writing a little bit lower so I don't run into the writing I just did. Since ED is congruent to CB, they've marked that, and that would be just the line segment there that they've drawn. So this is what goes after the so. The arc ED is congruent to the arc BC, or CB. I'll go in the same order I did above. I have to do a lot of this just by listening since I don't have a stylus to write with today at home. Okay. In the last box, congruent arcs have congruent central angles. So if they tell us, I'm going to write over to the side so I can write bigger. If they tell us that arc ED is congruent to arc BC, then we know that angle EAD is congruent to angle, I wish I could do better than this, sorry guys, BAC. So basically, if you have central angles, those are angles that come out of the circle, and you know a piece, either the angles are congruent or some other piece is congruent, it basically means all these things are equal. If I have equal angles, I have equal arcs, I have equal chords. And if I know any one of those things is marked equal, then I know all those other two things are equal. So that's kind of what they're trying to say in these boxes here. Okay, in this picture we see that we have congruent chords. We have chord TV and chord SW, and they're marked congruent. So if you know you've got congruent chords, you could make a little equation here and find out the actual length. What I'm going to do here is I'm going to have to set the amounts. They mark the chords. One of them is marked 9n minus 11 degrees, and we're going to say that's equal to 7n plus 11 degrees. So I got to solve for n, and then I'm going to have to go plug it back in to get the actual chord, what do they want? Chord length of WS. This is a chord, so if you have a symbol over it, it would look like that. We might just talk about the length of WS and not write a symbol over that WS there, but if you wanted to, it would just be that little length of segment. All right, I'm going to move these 7n's over to the 9n's. I'm going to subtract 7n from both sides. And that would leave me with 2n minus 11 equal 11. Oh, gosh, that's bad, guys. Let me mark through that. 2n minus 11 equal 11. If I add 11 to each side, gosh, I wish they would pick up better. It would be 2n is 22. And if you divide both sides by 2, you get n is 11. Now that's not the length though. Remember, that's just what n is. WS is 7n plus 11. So let me write in a different color so you can see where I'm kind of going with this. 7n, well, n is 11 plus 11. Okay, well, 7 times 11 is 77, plus another 11 is 88. The actual length of the segment is 88. Okay, now down at the bottom, number 7, circle C is congruent to circle J. What does that mean? Before I go on further, I might want to think about what that means. The only thing they told us about congruent circles is they have congruent radii. So that must mean all the radii are congruent. So we're going to keep that in mind. Actually, I'm going to write it down here. Let me go set the all radii congruent. So that means that if I want to write down some radii, CD equals CG equal JN equal JM. That's what I know from that statement right there, and I haven't even gone on, and I already know that I could put a mark on them. I'm not, just because it's been hard for the app to pick up my finger. So I don't want to get a bunch of marks that get in the way. And the measure of angle GCD is equal to the measure NJM. So we have two congruent angles. Find NM. Well, NM is right here. You see it. Okay, since the two angles are congruent, then their chords are going to be congruent. So all I got to do here is set up a little equation. 14t minus 26 is equal to 5t plus 1. 14t, that's 14t minus 26 is equal to 5t plus 1. And again, it's not picking up really well. I'm going to move all the t's to one side. I'm going to subtract 5t from each side. That's going to leave me with 9t minus 26 is equal to 1. Let's add 26 to each side. I'm trying to get that t by itself, but I wanted to get all the t's on one side first. 9t is 27. And if I divide both sides by 9, I get t is 3. Okay? So if t is 3, and they want to know how long nm is, I just have to go plug 3 in for t. 5 times t plus 1 would be 5 times 3 plus 1, which is 16. So the length of nm over here at the side is 16.